Okay, so we are officially beginning. So welcome to everyone to the NASA Aries Classroom Connection webinar, The Moon, a World Full of Wonder and Opportunity. We are broadcasting from the NASA Johnson Space Center here in sunny Houston, Texas. And we welcome all of you all around the nation, or around our continent, I guess I can say. We welcome all of you. For some of these opening remarks, I just wanted to actually to say that we have approximately 23 states plus Mexico that are joining us for this webinar today. Now, the colors on this map, some of you are joining live, and that's if you're in sort of this dark red coloration. Some are only going to be able to listen to the archive presentation. But in any case, 23 states plus Mexico, students in grades 1 through 11, we are thrilled to have all of you with us today. Our featured speaker today, Dr. Sam Lawrence, here at the NASA Johnson Space Center. We are very, very lucky to have Sam with us. He's an extremely busy scientist. He is an expert in the moon and planetary science, and you're going to learn more about Sam when he introduces himself. But I definitely want to thank Sam and welcome him to our webinar today. The third thing I want to mention, and Sam might bring this up a little bit in his talk, International Observe the Moon Night. This Saturday, October 28th, events all across the world, and you can see this map in the lower right-hand corner. If you're in one of these areas, you can go to this website. You can see where there may be events happening. And International Observe the Moon Night is all about an appreciation and an understanding of our moon. So if you do nothing else on Saturday, look up at the moon and think of some of the things that Sam is going to tell you today. So the last thing I'll mention is we are already planning our next potential webinar event. And for you teachers out there, this is, again, another one you're not going to want to miss. We're planning to give you a virtual tour of our lunar laboratory with all of our moon rocks here at the NASA Johnson Space Center. And we're tentatively planning on that for November 6th from 2 to 3 p.m. Eastern Time. So stay tuned for more details. I will get information out to all of you on that. So with that, again, to all of you around the globe or around the continent and around our area here, welcome. We are officially beginning. So with that, I'm going to turn it over to Dr. Sam Lawrence, and he's going to start sharing with you a little bit about the moon, a world of wonder and opportunity. Now, just stand by here, Sam. I'm going to just make one little adjustment here, and you are good to go. So, Sam, welcome. If you'll introduce yourself and share with us.
Okay. Thank you, Paige. I am delighted to be here. I'm recovering from a cold I picked up last week, so I'll croak my way through the presentation here. My name is Sam Lawrence. I am the Chief Lunar Scientist here at the Johnson Space Center. I'm part of the Astromaterials Research and Exploration Science Division here at JSC, and I'm also a member of the Lunar Reconnaissance Orbiter team. So I grew up in the early 1980s, and it was an amazing time. The space shuttle had just started to fly, and people my age were told that we'd all be living in space someday. And so I remember watching the first launch of the Columbia, and this really got me excited about science and technology, and I knew I was going to be working in the space industry. And so I actually thought I was going to study aerospace engineering, and then I read a book about the moon called To a Rocky Moon. You can see a picture of it here on the slide. And right around the time when I was in high school, the first President Bush announced a plan to send the U.S. back to the moon, this time to stay, to build the foundation for going to other planets beyond. And I thought, I was really excited. I was like, I want to participate in this. And I realized that it wasn't, the important questions weren't how do you fly in space, but how do you survive once you get there? How do you thrive? So I studied geology when I got to college. And through a series of fortunate coincidences, I wound up having the opportunity to join the Lunar Reconnaissance Orbiter team after I was finished. And LRO is an amazing mission. We've been now in orbit around the moon for 9 years, and it's fun. It's something I hope you all get a chance to experience, the feeling of knowing that something you've worked really hard on is launching into space on a rocket. And it's also fun to be part of a team. When you're part of a team that's working hard and working on behalf of the American people, it's just very meaningful and it's fun and it's very rewarding. And we have a very large team as part of the LRO project. I was part of that and still am part of the camera team at Arizona State University.
So go ahead, Sam.
So I guess one of the questions, my first question to the group was, I wanted to ask, what do you know about the Lunar Reconnaissance Orbiter? It's one of NASA's flagship missions, and so I'm curious to hear how much you all have heard about it. So you can go ahead and put your answers into the chat window, and we'll take a look at them.
Excellent. So think about what you may know about this mission, and maybe you don't know much, but that's what we want to find out. So go ahead and put your answers in the chat window, and we'll see what some of you have to say. So Duxbury Senior Center doesn't know much, so that's why you're here. UNT Health Science Center is saying we're at the moon. Some of you are mentioning you don't know anything about the LRO mission. Otis Field, a few kids have heard about it but don't know much. Shaker Heights says it's a mapping mission. Hamilton Early Learning Center, it orbits around the moon. Excellent. Multiple cameras. You don't know much about it. It's a spacecraft, JCTMS is saying, that orbits the moon looking for details. So, Sam, we really need to get some of these groups up to date because the little that they know, we're going to certainly enhance it. And Easton Elementary, one of our groups from Maine, they don't know much, so they're going to learn a lot today. So share with us, Sam.
Okay, well, let's get started then. So I guess the most important thing is, and one of the things and why International Observe the Moon Night is so important is that I find that most people don't, especially if you live in cities, don't bother to go just stop and look at the moon. It's cloudy, it's light, you don't really see it, but it is the brightest object in the night sky. And for early humans, it was an essential part of the rhythm of their existence. They used to hunt using moonlight. They used to plant there and harvest their crops based on the lunar month. And so the moon has always been of profound importance to human civilization. And you can see on this chart a size comparison. The moon is about the size of a continent. And many people call it the Earth's eighth continent. If you were to put the moon over the United States, it would basically be the same size as the continental United States. And it really is only a few days away. It's not that far. We can reach it. It is about 250,000 miles away. And as you get closer to it, and as you can see it from orbit, you discover it is a stunning world in its own right, full of wonder and opportunity. This is an LRO picture of Copernicus. And we did go to the moon in the late 1960s and early 1970s, excuse me. We flew American astronauts to the moon. This is a picture of the Apollo 15 launch from Cape Canaveral on a Saturn V, very similar to the one we have here at JSC. And during the Apollo missions, we landed 6 times on the moon, and we explored some of the surface. We actually explored an area with astronauts that's roughly the same size as a large shopping mall. That's the sum total of what we've explored on the moon, something the size of your local shopping mall. So the moon, as I stated, has a lot of surface area and amazing things that no human being has ever seen before. And when we landed on the moon for the first time, this is a picture of Buzz Aldrin standing on the surface of the moon near the lunar module. We just were seeing whether we could do it. So we didn't really go that far. We didn't really do a whole lot. We only stayed on the moon for about 2 hours. In 2011, we dropped my spacecraft, the Lunar Reconnaissance Orbiter, down to very low above the moon and took this picture of the Apollo 11 landing site. So you can see off to the right, this sort of line right here, those are Neil Armstrong's footprints preserved for all eternity in the lunar soils. This is the Apollo 11 descent module, the Eagle, sitting here on the surface of the moon for the last 5 decades. Here's the camera. I took a picture of the first moonwalk. Here's the science and experiments package the astronauts left behind. And you can still see all their little footprints right here. And so you can see here that the area explored on the first lunar landing during Apollo 11 was roughly the size of a baseball diamond. That's as far as they ever went from the lunar module. They didn't really get that far. They only are on the surface for a little under 2 hours, like actually exploring, and they only stayed on the moon for about 20 hours. So by the end of the Apollo missions, the astronauts were carrying small cars powered by batteries called the Lunar Rover, and this let them go farther and do more. And they carried, and all the astronauts had been trained. They understood what to do on the surface, and so they did amazing things. And it's safe to say that the Apollo missions redefined our understanding of the universe. And if you can remember to that picture that I showed you of what the Apollo 11 astronauts did, they only explored an area the size of a small baseball diamond. Here, using their car, you can see how far they went from the lunar module, and you can see each one of these little dotted lines shows where they drove. And they drove over, on Apollo 15, they drove over 30 kilometers, which is amazing, especially when you consider that they started out just by walking a few hundred feet.
And notice, now you just kind of gave away the answer.
I gave away the answer.
But one of the things we wanted to point out is, you know, this distance, and you can still let us know in the chat window if you'd like in terms of the distance, the number of kilometers traversed during Apollo 15, because maybe you didn't hear Sam say it. But reading graphs and visualizing data in multiple forms is so important. Is that right, Sam?
Absolutely right.
And so the image that he was pointing out is certainly extremely valuable. However, the traverse distance graph actually really sums up some of that information. So if you want to entertain me, how many kilometers were traversed during Apollo 15 using the information on the slide? You can put your answers in the chat window. I'll just see if any of you were really listening to my question. So Duxbury is saying 37 kilometers. Palm Springs North is mentioning the possibility of 107 kilometers. Chester High School, 33 kilometers. Shaker Heights, Vintage Magnet, Pac 94 are right around 33 and 32. Otis Field Community and Allen Academy are all saying about 33, and I see a lot of other 33 kilometers coming in. How do we know, according to this data on this screen, Sam, what the actual right answer is?
Well, we know 2 ways. The lunar rover had an odometer on it, and so as it was driving on the moon, we sort of measured how far it had gotten. And then later on, once we got into lunar orbit with the Lunar Reconnaissance Orbiter, we actually made detailed measurements. We could see where the astronauts had been to, and we sort of added up, we measured it on a map, how far they had gotten.
Awesome. And of course, the graph right up here kind of gives us that indication of Apollo 15, and you follow that line across, and it looks like we're right about 32, 33, just as the majority of the groups have mentioned. Great answers.
So I love this picture. This is the Apollo 15 lunar module sitting on the surface of the moon at Hadley. And you can see here, out in the distance, this was taken, the astronauts had driven up the side of a mountain, and they stopped for a minute to take a look at their home on the moon and took this picture. This is a wilderness. This is the edge of human experience, a true frontier. And I look forward to the day when this is no longer a frontier, but a place where humans can go easily and do whatever they want to do. So we actually brought back over 2,200 separate lunar samples during the Apollo missions, and those are all stored right here in the building where I'm sitting at the Johnson Space Center in Houston, Texas. And these samples are critical for not only understanding the moon, but the rest of the solar system. And using these samples, we actually understand a lot more about the moon than we did before we went there in the early 1970s. We learned that the moon is actually a planet, is a lot like the Earth. It has a crust and a mantle and a core. We learned that if you look at the moon on a clear night and you see the dark patches on the moon, those are all a kind of rock we call basalt, and that's very similar to what you see forming on the big island of Hawaii. We learned that the moon probably formed in a giant impact with the primordial Earth about 4.4 billion years ago. Unlike the Earth, the moon has no weather, it has no liquid water, and it doesn't have large-scale plate tectonics the way that the Earth does. And so rocks and landforms survive on the moon for billions of years. We also learned that the moon is lifeless. There's nothing living there. There never has been. There's no fossils or organic materials or anything like that. There's no evidence anything ever lived on the moon. But perhaps most importantly, we learned that something could actually live there. We learned that the moon could eventually be settled by human beings. It has the resources and lots of places where humans could go live there successfully. So starting after the Apollo missions ended, the Russians flew a few missions to the moon, and then we kind of stopped going for various reasons. But during the 1990s, we started to fly missions to the moon again. And over the past 20 years, wow, that makes me sound old. During the past 20 years, we've flown a number of missions to the moon, starting with Clementine, the Lunar Prospector, the European Space Agency flew a mission called Smart 1, the Japanese flew one called Kaguya, the Chinese have flown a series of 3 Chang'e missions, culminating in a lunar landing in 2013. And the U.S. has flown the mission called L-Cross, the Lunar Reconnaissance Orbiter, the Lunar Atmospheric Dust Environment Explorer, or LADEE, and a mission called GRAIL. And all of these missions have fundamentally changed our viewpoint of the moon, and we now know it to be a far more interesting and exciting destination for exploration than we ever thought in the past, even while we were sending humans there. So one of the missions that we flew was launched in 2009, but we started building it in 2007, and it's called the Lunar Reconnaissance Orbiter. And here's a picture of the launch. And that was an amazing day. If you've never had a chance to see a rocket launch, I hope you get a chance to experience it. It's like nothing else on Earth, literally. It's just a very exciting feeling to see something that you've worked on really hard flying into space. And it was really phenomenal. And after we launched, we all flew back from Cape Canaveral to Arizona State, where at least my part of the mission is controlled from. And we started to actually work on exploring space. So I'm part of a team called the Lunar Reconnaissance Orbiter Camera, which is actually 3 cameras. And the first one is called the Wideangle Camera. So here's a picture of it. It's about the size of your fist. If you clench your fist, that's about how big of the Wideangle camera is. Here's a picture of me at 3 in the morning in July of 2008. And this is the instrument that's flying around the moon right now. We worked really hard. We got it ready. We delivered it to NASA. It was put on the spacecraft and launched into space. The wide-angle camera takes color pictures of the moon. And here's one of them. So using the wide-angle camera, we can actually take global maps of the moon. We've collected all these data. We've stitched them together, kind of the way you do it with one of those panoramas on your phone. And we made the most accurate map of the moon that we have ever had before. And here's a picture of the near side of the moon. This is what you can see with your naked eye from Earth. And over here is the far side. You can't actually see this unless you go to the moon. And this is the side we never see from the Earth. And so now we have very clear, excellent maps of the near side and the far side. And it also turns out, and I mentioned previously, that the moon is full of things we can use to live there. And one of them, we can actually use our wide-angle camera to see some of these resources. And it turns out that these, everyone can see these dark patches here. These dark patches are blobbies of titanium. They're glass beads, they're made of titanium. And that's one of the most readily accessible lunar resources because we can actually go pick these up, scoop them up, heat them up, and get oxygen and water out of them. So that's really exciting. And thanks to LRO, we now fully understand where all of these resources are. We've also been able to take three-dimensional pictures of the moon. So this is what's called a topography map. And this shows the sort of the shape of the moon. The blue areas are areas which are low, and the reddish orangey areas are areas which are tall. And you can see here that the moon has tremendous extremes, going from really tall mountains to flat valleys. And again, most human beings have never seen any of this before with their own eyes. There's also two telescopes called narrow angle cameras. They're bolted onto the side of the spacecraft. And they take big, small images. They take images which are about ½ meter per pixel. And for those of you who don't know what a ½ meter is, it's about 3 soccer balls in diameter. And to demonstrate what that looks like, here's what that actually means. So here's a picture of a lunar module on the surface of the moon taken by Lunar Reconnaissance orbiter cameras. This is the Apollo 16 lunar module. And you can see here, here's a picture of a lunar module being prepared for launch at the Kennedy Space Center. And here are some human beings for scale. So this lets you this shows you just how powerful these cameras are. We can see all kinds of little details. For example, this little black spot right here is the American flag left on the surface of the moon. We can also use these telescopes to take 3D pictures of the moon. This is actually, it's very useful. We like to have these pictures to plan future missions, but it's also very complicated, and so we don't really do it that often. But these pictures will be used by, the 3D ones especially, will be used by future robotic and astronauts, future robots and astronauts who land on the moon. Here's a picture of the Apollo 14 landing site. Here's the Apollo 14 lunar module, and again, you can see the footprints of the astronauts going all the way up to the rim of this crater, and then they walked all the way back. And we can see exactly where they went to, and we can almost even see which rocks they picked up from the surface of the moon. So I have a question for you guys. What types of landforms or processes do you think that the LRO cameras have imaged on the surface of the moon? Go ahead and put your answers in the chat window.
So think about what you know, think about what you've heard, what features or processes do you think these cameras have taken images of, and we'll see what you come up with. And for those Texas groups, you know, these landforms I know are part of your standards. So we got a lot of craters from Chester High School and E.M. Daggett, craters, valleys, veins. Harmony Hills is saying valleys. Allen Academy, craters, lava flows, rocks, hills. Scarps and mountains from Shaker Heights. Hamilton Early Learning Center, landforms like craters and valleys, mountains. Otis Field Community School adds in hills. Murfreesboro Middle School says impact craters. Definitely lots of them. Now, Edna Drinkwater mentioned titanium, which is a type of material, it's a mineral. It's a mineral, so that is certainly found, and he has talked about that. Some ditches from Harmony Hills, rocks, or some mini volcanoes. Who was that group that said mini volcanoes? That was Palm Springs North Elementary. Mountains, craters, our Mexico group says valleys with minerals. Edna Drinkwater School is mentioning the possibility of ice. Moon rocks and dust is added in from Otis Field Community School. So, Sam, I am actually pretty impressed.
I'm very impressed
of some of these answers here. So let's see some of these landforms. I didn't see many processes, but I saw a lot of these landforms. So let us know what LRO is seeing.
Okay.
Great answers, by the way.
So you basically answered with everything I was about to tell you. So first of all, we've imaged lunar volcanoes that we never knew were there before. I mean, we knew they were there, but we didn't know they were volcanoes until my mission got to the moon. These right here are silicic volcanoes, very similar to ones you find in Africa and Russia. Just a very unusual composition. They look like typical volcanoes. And this tells us something, but it also tells us there's always something new to explore because we don't know everything there is to know about the universe, and that's why we launch missions and people into space. We also discovered this series of very unique miniature volcanoes that appear to indicate that the moon might still be geologically active. We found about 70 small deposits of these very unusual landforms that indicate they are volcanic, and they apparently erupted between 60 and 200 million years ago. Well, we used to think the moon had stopped being geologically active about 3 billion years ago. And that's a pretty big difference between 60 million years and 3 billion years ago. So we don't really understand why these are here, but we very much would like to. And so these landforms have become very high priority destinations for future robotic and human exploration. And so if we go to some of these recent volcanoes, or possibly recent volcanoes, I should say, because some people don't think they can be that recent because it contradicts everything we knew about the moon. But if we go to one of these locations and we explore them with people and bring back samples, we'll understand so much more and answer this question definitively. We've also seen evidence for multiple volcanic eruptions. If you look at this, this is my favorite picture from the LRO mission. It is spectacular. I used to show it to my students and go, which planet is this? And they always used to say Mars, but it's not. It's the moon. And if you see these little flat layers right here going all the way across the image, each one of these is an individual layer of volcanic materials that erupted and was in place there and now is preserved for all eternity. And so we now understand that we've seen very complicated geology on the surface of the moon. Okay, so we've also seen pictures of lunar caves. I think I saw someone ask about that in the chat window a few seconds ago. So my question to all of you is, if the sun is rising from the left, which image, A, B, or C, was taken in the morning, at noonish, or in the afternoon?
So this is an interesting question, and we want to get your thoughts on this. So one of these pictures was taken in the morning, the afternoon, and at noontime. So in the chat window, we're interested to see what your perspective is. And again, the sun is coming from the left. So Cross Timber says B is in the morning. Pack 94 says B the morning, C at noon, and A in the afternoon. A is the afternoon. And if you want to give us any indication as to how do you know this, that would also be good. So we have CBA from Miss Gonzalez's group. J.H. Rose says A is the afternoon. So, and I'm thinking about this myself. Palm Springs says A, C, and B. So B is the afternoon, C is noonish, and A is in the morning. Boy, this is tough to keep track of. I guess I should really be thinking about myself. What is the right set of answers? Otis Field seems to have 1B, 2C, 3B. Well, 3B. Our Mexico group says A is the morning, B is the afternoon, and C is noonish. That's very clear. I can understand that answer. Thanks for that clarity, our Mexico Academy group. A, C, and B. So we had actually some different answers on this. So and Lathrop, our group from Alaska, says 1 is A, so in the morning is A, 3 is in the, I'm getting confused with my own answers, and C is the afternoon. Well, I think I've confused myself, Sam. I think we need to clear things up. Can you help us out here?
So here you go. So this is the these are pictures of the single cave in the Marias Hills region of the moon. This one is the morning picture. Here's the noonish picture. Here's the afternoon picture. So I think most of the students converged on the correct answer. You can see what we tried to do for this picture right here. We actually tried to tilt the spacecraft down so we could see underneath the overhang and see just how far back they go. So using LRO pictures, we were able to see that it went back about 60 meters, give or take. And so one of the answers seems to be, and I think someone mentioned in the article that just came up in the Washington Post a few weeks ago about the study that had been done by our Japanese colleagues, indicates these are in fact lava tubes that can extend for far distances beneath the surface of the moon. These are fantastic locations to build lunar habitats. They provide shelter from radiation, they provide shelter from micrometeorites, a constant temperature. I could easily see a scenario where we're building space stations or even hotels or things like that in caves here on the moon discovered by LRO. We found about 200 of these things on the surface of the moon, and an additional several, I actually don't remember how many, but we found between 10 and 15 on Mare surfaces. So all in total, there's quite a few of these collapsed lava caves on the moon, and they're prime destinations for human exploration. And here's another one. So this is essentially a collapsed lava tube. And what happens is, on the moon, is that there is no weather. And so these lava tubes are formed just the way that you would form a river here on Earth, except the flowing liquid isn't water, it's hot magma. And it's magma that's erupting at well over 1,000 degrees Celsius. And it's so hot, it's literally carving its way through the surface of the moon. And that lava will eventually roof over like this, and then occasionally it can collapse. And we think that sometimes the collapses are caused by meteorites hitting the surface, and then they poke little holes in the ceiling. And that's kind of what you're seeing here. So this is a collapsed lava tube. You can see there's actually a natural bridge walking across here. And I just always stop and I look at this picture, and I go, imagine the picture you'd take if you were an astronaut sitting on this natural bridge. I think that'd be a really cool picture to take. Here's another picture. This is one of the most famous pictures we've taken during the mission of LRO. This is Tycho Crater. This mountain is almost 2,000 meters high. And can everyone see this little rock right here? It looks really little, but as you zoom in, this boulder here at the top is the size of a baseball stadium, the whole stadium. So it would be the size of Sun Devil Stadium at ASU or the Silver Dome in Pontiac. This is a humongous boulder. How did it get there? We don't know. We would certainly like to go there and find out. And all over the moon, we see craters at all kinds of sizes and all kinds of scales. This cratering is the fundamental geologic process in the solar system. And you might say, well, geez, I don't care, but you do care, because 65 million years ago, you're here because of a crater. And the dinosaurs were taken out, mammals were able to rise to the top. So cratering is a very important fundamental solar system process. And on the moon, we see craters of all sizes. This is a crater called Giordano Bruno. We think this crater could have been observed. We think that monks in the 1600s might have actually seen this crater form on the surface of the moon, or at least seen the fireball that happened when it was formed. And all over the moon, we see these amazing examples of craters. And when we look closer, we see all kinds of fascinating geology. It's really phenomenal. This right here is, these are all flows of melted rock. So when a crater forms, it gets hit by essentially an asteroid coming in super duper fast, and it hits the moon with the force of a nuclear weapon, or possibly bigger. And that impact and that explosion melts the rock. And what you're seeing here are all the crazy patterns formed by the melted rock. And as scientists and as explorers and as planetary scientists, we care about the melted rock because we can actually go to these craters, collect samples of these melted rocks, bring them back here to Johnson Space Center, and then do radiometric age dating, looking at their nuclear chemistry and see how old these rocks are. And it's pretty amazing. And we're seeing all kinds of these amazing landforms on the surface. Here's another set. So this is another pool of melted rock. You can see here, you can actually see preserved in the frozen rock the swirls where the where the lava actually was flowing down into a crack or a fissure in the surface of the moon. And you see all kinds of little swirls are off here, off to the right, in amazing patterns. So this particular crater has again become a very high priority destination for future human exploration. And here's some more. Here's some more cracked impact melt here in the surface of Giordano Bruno crater. Each one of these little polygonal textures is about 7 or 8 meters across, and so that gives you a sense of the scale. We've also seen landslides, and so if you take a look here at this particular image, this is a landslide. Now, we did not see this one happening, but we have actually been trying to take before and after pictures of the surface and essentially all over the moon to see evidence for surface changes. Now, landslides can be caused by a number of reasons. They could be caused by a small little impact causing materials to just fall downhill, or they could just be caused by a moonquake. And so this is a, it's, first of all, it's a beautiful image, but secondly, this tells us something about how the moon operates. We've also seen very small scale faults. Now, if you know anything about geology, you know that rocks crack and it can slide in different directions like this. And you can see on this picture, here's where some rocks were going this way and some other rocks were going this way, and they overprinted one another. And you can see little fissures right here. And so we've found several thousand of these little tectonic faults, these little examples of faulting and jointing. We didn't know they were there. So this has been one of the major new discoveries of the LRO mission. Now, we've also mapped the lunar poles in great detail. And this particular picture doesn't actually show the moon, and instead shows how much sunlight hits every square inch of the moon, at least in this region of it. So bright areas indicate a region gets a lot of sunlight, and the dark areas indicate that a region doesn't get much sunlight. And we did this by taking tens of thousands of pictures and averaging them, and then doing clever things with computers to see how much illumination was in every single spot on any one of these images. We made this map. And that's important because on the moon, as you can see, there are areas where the sun never stops shining, and there are also areas where the sun never shines. And that's because of the fact that the moon is right here, and because the moon is topography and is at kind of an angle, the sunlight comes in and creates these areas of permanently shadow, where the sun literally never shines. And that means that there's water ice, there's volatiles, there's things right there, there's essentially water in various forms and various components, and OH molecules and H2O molecules, other species that you can use for astronauts, to stuff you drink, stuff you breathe, and for rocket fuel. Another instrument on LRO has been able to see evidence of surface ice. So if you look at the moon and look at some of these permanently shadowed regions, we see evidence for frost, for areas where there is frozen water. And these are some of the most valuable areas in the entire solar system, because this water is a resource that we can use to enable more affordable and capable voyages to Mars and beyond. So every day, the mission is still in orbit around the moon. We've been now in orbit for 8 years, and we were recently approved to continue orbiting the moon for another year. And so one of the great benefits of this is every day we're taking more pictures. We haven't managed to image the entire surface of the moon yet, so we'd like to take at least one picture of every spot on the moon, and we will continue doing that as long as we can, because these are the images that will define where astronauts go on the moon for the next 100 years. So I'm going to stop here and ask a question. Which of these features, the ones that I just shared, are the most interesting to you and why? Volcanoes and volcanic features, impact craters, layers, caves, erosion and mass wasting, tectonics, or the polar regions? And put your answers in the chat window.
And I'll be very interested to see, Sam, what folks found interesting, because there really is so much. But if you had to pick one or two things, so Allen Academy says polar regions and the possibility of resources for for future habitation. UNT Health Science, also polar regions. Duxbury says the volcanoes because of it showing recent activity. And the Drinkwater likes those caves. Shaker Heights says the bridge, and it's so interesting, and they didn't even know anything like that existed. PAC 94 also a vote for the polar regions to find out more about water and the possibility of potential life. Polar regions from Palm Springs North Elementary. Grapevine likes those caves. Otis Field Community Center likes the volcanic features and those polar regions. Volcanoes, yeah, Hamilton Early Learning Center 4 and 7, so the caves and the polar regions. Lathrop Caves for homes, poles for waters. Vintage Magnet says volcanoes are the most interesting because they might still be active. Murfreesboro, polar regions, volcanoes and tectonics. They couldn't leave it to just one or two. They had three favorites. York Middle School, volcanoes and caves. Polar regions from Palm Springs North. Cross Timbers, polar regions. So a lot of polar regions and these volcanoes. And I think it's interesting, and even our Mexico group, Academia Aeroespacial, says caves and volcanoes. This whole idea of water and current potential activity is, I think, really interesting as these caves are. And people didn't know that these even existed on the moon, and they do. So we've got, it seems like between the volcanoes, caves, and polar regions, ice and holes in the ground and hot stuff, they seem to have the interest of many of our groups. Do you have a favorite?
I think everything needs to be.
Everything needs to be explored, and they're all your favorites.
Yeah.
Awesome. So let's go on. Great answers there.
So this is a picture we took from lunar orbit, and this is actually our planet, the Earth, taken from lunar orbit. And I'm looking forward to seeing a new generation of explorers having a view like this. From the surface of the moon at a lunar base, a lunar outpost, you could look up and see the entire spread of the Milky Way. You could see our own home planet, and you could explore an amazing world that's full of wonder and opportunity. And so if you're interested in finding out more about the Lunar Reconnaissance Orbiter mission and the Lunar Reconnaissance Orbiter Camera, here's the website, http://lroc.casu.edu, where we post pictures and captions every so often to try to highlight some of the more amazing and unique things we've seen in our mission. And so here's a picture of the last American spacecraft to land on the surface of the moon. This is the Apollo 17 mission. Right here, this is the Apollo 17 lander. You can see the American flag sitting right here, waiting for a return visit. And after 5 decades, I think it's high time we sent the United States back to the moon to finish what we started back in the 1960s. So with that, I will take any questions you might have. I see some good ones back here in the chat window.
Absolutely. And first of all, thank you, Sam, for sharing this amazing information. It seems like so many of our groups have certainly learned not only about LRO, but about some of these amazing features. And it has sparked a lot of questions. And in our last 15 minutes or so, we want to try to get some of your questions answered. Now, I've been jotting down some of the questions that have been coming in. So if you want to type more in the chat window, please feel free. But here's a couple of questions that I saw come up. One was from Duxbury Senior Center, and you were mentioning the dates and the ages of when these volcanoes may have flowed and some of these lava flows. How can you date these flows is what Duxbury Senior Center wants to know.
Well, that's a very good question. So basically, in a nutshell, when you look at the moon, you see craters. And if you've ever cut down a tree, you know that the older the tree gets, the more rings you get. And so you can count the number of rings on a tree. It's basically the same thing. So with an older surface on the moon, it has more craters because it's been exposed to the space environment for longer. With a younger surface, it has fewer craters. So for some of these volcanic features, they have no craters. And the only way we know of where that could be the case is if they erupted pretty recently. Because if they erupted, 3 or 4 billion years ago, they'd be covered in craters. And they aren't. And so that's why we think some of them are pretty young.
That's awesome. And crater counting is a strategy that is used for many planetary surfaces to sort of age date
That's
them.
right,
Is that
yes.
correct?
And we actually are able to do that because of the Apollo samples right here at the Johnson Space Center. When the Apollo astronauts landed on the moon, we were able to bring them back to our laboratories here in Houston, where all lunar samples will always be brought back. And we were able to analyze them using really sophisticated analytical instrumentation and figure out how old they are through radiometric age dating. And so because of that, we can do that all over the solar system.
That's awesome. Excellent question, Duxbury, and they're from Massachusetts. Now, J.H. Rose High School, our group in North Carolina, had asked, regarding these volcanoes, would you call them active, inactive, extinct? What do scientists think about these volcanoes on the moon?
I'm not sure scientists know what to think about the recent volcanoes. It's a fairly new discovery that we only made in the last couple of years, and we're still trying to figure out why they're there and what they could indicate for the solar system. I would say nearly all the volcanoes on the moon are probably extinct, and so there's only this very few ones where I think they could still be geologically active, but maybe not. I'd say it's a mystery. It's one of the many reasons why we have to go back.
And that's one of the great things about science is the more you learn, the more questions you start to consider and think about, and that's sort of the cycle of continual science
That's
and
right.
exploration.
That's how we fly.
Absolutely. So Otisfield Community School, they asked just a pretty interesting question about how did the moon get its name? Why do we call the moon the moon?
That's a good question. I'm not sure I really know the answer to that. At least it's always had a singular name in most cultures. And so,
yeah, you think of other planetary worlds, their moons have names, Phobos and Deimos, Enceladus. All these different worlds out there have different names for their moons. So that is a good question.
That's a good question. I don't know the answer to that.
All right, and that's okay too. If we find something out, we'll share it with you. Let's see. Harmony Hills has asked a couple of times, I believe, about making pods on the moon.
It's an interesting question. So one of the things that makes space exploration so expensive is the fact you've got to bring everything with you from Earth. One of the great benefits of actually going to a place like the moon is you can use the resources you find there to make new technologies. So you don't have to bring them all from Earth. And so I would imagine that at some point in the future, when we have people living and working on the moon, they will make as much as they possibly can using lunar materials because that saves money and it saves time.
Awesome. Hey, here's one that came up earlier also from Cross Timbers, our group in Grapevine, Texas. You mentioned that there's the core and the different layers of the moon similar to Earth. Do scientists also know the temperatures at these different layers?
We have educated guesses and essentially hypotheses. During the Apollo missions, the astronauts actually drilled holes in the surface of the moon and dropped down temperature thermometers. And from those measurements, we've been able to figure out how hot the moon still is today and try to figure out the temperatures of the core, the mantle, and the crust. But we won't really know the answer to that question until we go back and collect more data.
Awesome. It's all about getting more and more data, and we can't wait to get more. So our Mexico group has asked, how does studying the moon actually benefit the Earth?
That's a very good question. There's a number of good answers to that. The first is that the moon really is the cornerstone of the solar system. And so we're not isolated. We are part of a larger universe, and everything that goes on around us in this galaxy does actually affect this planet. And it behooves us to understand exactly everything we can about the environment that surrounds us. So to a first order, we're not isolated from the universe, we're part of it, and we need to understand it. And so that's always my sort of answer to that question. But in terms of developing a workforce that's skilled in science, technology, engineering, and mathematics, Space exploration serves an important role, and especially in lunar science, in understanding exactly how, how to live and work on other planets. We have to, if we are really going to convert humanity to a multi-planet species, the moon is the most logical place to get started doing that.
Awesome. Now, here's a question from Hamilton Early Learning Center, and they're our group from La Crosse, Wisconsin. They talked a little bit about how these caves formed, but if you can sort of reiterate a little bit on how do the caves form and how do the volcanoes on the moon form?
That's a really good question. So the caves, I think I hinted at this previously, they're actually lava tubes. And so if you've been to the Big Island of Hawaii, you can see that the lavas, the hot ones that are up right from the volcano, they can actually tunnel through the subsurface because they're hot and they're essentially carving their way through. So that's how we think they formed on the moon, a very similar kind of process, but we're not really sure. It's a pretty good guess. It's actually my guess that that's exactly what's going on, but we won't really know until we get there and explore. And so actually sending a mission to one of those caves is, I think that'd be a really cool thing to do. I think that would just be a lot of fun.
Even the students thought so too.
So I kind of think that'd be a great thing to do. What was the other
and the volcanoes, how do they form?
Right. So the moon actually used to be part of Earth, and so basically when that giant impact happened, it made the moon really, 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 really hot. And that melted everything. And from that original sort of global melting, it melted everything on the moon. And the moon also contains radioactive elements the same way Earth does. And so the combination of those two factors resulted in a very active, volcanically active lunar surface, where you've got the volcanic, essentially the radioactive stuff in the core and the mantle, heats everything up, and that causes magma to rise, and it erupts to form volcanoes. And so that's one of the reasons why we see this amazing diversity of volcanic landforms on the moon.
Could also impact craters that strike the surface cause some melting as well? Maybe not a volcanic feature, but a volcanic flow?
It does both. So basically when an impact hits the moon and causes the rocks to melt, it behaves, it's a melted rock. So when you have a volcanic eruption, it erupts as a melted rock. And when you have an impact, it creates a melted rock. And that effect is the same, melted rocks. And so you have these landforms that look very similar to volcanic landforms, but they're actually all impact melts.
Interesting.
Yeah.
I noticed on one of the images you had of the far side of the moon, there was a crater sort of in the upper portion of it that seemed to have this darkish material
right, so
on there.
We do not understand why there's so little volcanic activity on the far side.
Interesting.
That's one of those fundamental questions that we would really like to know why that is.
Very interesting. Well, now, PAC-94, this is a scout group from Iowa, I believe. They actually were interested in knowing, you mentioned something about the flag, but can you see the flag with these LRO images?
We can see the shadow cast by the flag in the LRO images, and so we see it at 5 of the 6 Apollo landing sites.
Ah, very interesting. So you'll have to look at some of those LRO images.
Yeah, so if you go to the lroc.cc.asu.edu website, we actually go through it and I think list which ones we can see.
Awesome. So here's a question from Murfreesboro Middle School from a small little town in Illinois. And they're wondering what's the strongest moonquake recorded? And can you actually record and detect these moonquakes? And if so, how?
So no. The Apollo astronauts left seismographs on the surface of the moon during the Apollo missions. And those seismic stations were nuclear powered, and they stayed on for, I think, about 9 years, I want to say, almost a decade. And for that decade, we measured moonquakes on the surface of the moon. And I believe the largest one was on the order of about a 5.5 on the Richter scale. Moonquakes happen very frequently on the moon. They can be caused by any number of factors, typically thought to be impacts, but the moon is actually, you would never feel it if you were on the surface, but it is, and there are a lot of tiny little moonquakes everywhere. They're very small, and they seem to be almost continuous. So when the Apollo astronauts were there, they didn't notice anything. And then when the seismographs were left behind, they recorded many, many moonquakes, but none that were significantly big. Certainly none you would really probably notice if you were staying on the surface.
Excellent question, Murfreesboro. Yeah. So Edna Drinkwater School, and they're a group in Northport, Maine. they're wondering, so how do you tell how tall a mountain is or how deep a crater is? How do you figure those things out?
Sure, that's a good question. So our spacecraft, the Lunar Reconnaissance Orbiter, actually carries a measurement laser. So if you ever watched your dad do carpentry, some of you guys may have seen him or her or your mom, for that matter, use a laser rangefinder to measure distances. You can actually time how long it takes for a laser to go and then bounce back to your receiver. And measuring that time, because we know what the speed of light is, and you know how fast a laser beam goes, you can measure the distance that it takes to get for the laser to travel from the spacecraft to the surface back to the laser. And by measuring that time, we can actually measure how high mountains are and how deep craters are for the entire moon.
And they've used these laser altimeters not only on the moon, but for Mars as well.
They've used them on Mars and we've used them on asteroids.
Yeah, and that's such an amazing technique. But also, if you're looking at an individual image that's not of elevation data, is it true that you can use sun angles and a little bit of trigonometry?
You can, actually. So you can actually take two images with different sun angles and then do a lot of math and figure out how high individual features in each image are.
Awesome.
So then you have to tie that back to the laser measurement.
Awesome. Excellent. So for those of you that like math out there, there's a lot of math that can be done on these images to figure some of this information out. Now, Vintage Magnet, a group from California in Mrs. Buck's class, they're wondering, so how deep is the deepest crater we've ever discovered?
It's about 7 kilometers deep.
7 kilometers deep. Can you relate that to something? So I don't know what 7 kilometers.
I should rephrase that. It's actually the lowest point on the moon is 7 kilometers deep. What that means. So if you looked, that's a good question. It's hard to put that into a human scale.
Yeah, 7 kilometers. So you figure some people run a 10K race, which is 6.2 miles, which is, 6.2 miles. So 7K, a little bit less than a 10K race if you think in terms of running distances. Yeah. So that seems pretty deep.
It's pretty deep.
Someone had, and I didn't write down their name, but there was a group when you were talking about the polar features, and it looked like you had a very, very dark spot. Could you tell how deep that hole or crater is?
But I don't have that number on the top of my head. But yeah, we can see, because we carry our own light source, the laser, we don't need to wait for the sunlight.
I see.
So.
And that's the same area where ice can potentially...
Right, so I think I saw a question about how did water ice get to the poles?
Yeah, I did.
And that's a really good question. So what happens is our solar system is full of comets, and these comets are basically giant snowballs. They hit the moon, and the water that arrives on the surface of the moon gets heated up, and then by the sunlight, and then it essentially bounces its way across the surface, and it keeps bouncing until, because it'll warm up, it'll turn into gas, it'll bounce around the surface, and then it cools off and it freezes and it keeps bouncing. And essentially what happens is that eventually over millions of years it all winds up in the polar regions.
So comets, is that how we got our water too?
I don't know. We need to do more sporting to find out.
And I love that we get the I don't know answers because, I think that is such a great thing to realize that there is so much science and discovery that still needs to be made, that it's an ongoing aspect that really we need to continue exploring. And actually, that brings me to a question from Otis Field Community School in Brownsville, Texas. They had actually asked, what do you think is the most important skills or work habits for students to foster during middle school and high school to set themselves up for lots of options for college and careers?
Sure. Well, I think for me the most important thing has been the fact that it's really important to be able to learn how to work in a team. You're going to encounter a lot of diverse viewpoints, a lot of variety of opinions, and it's important to be able to function to blend those and make sure, because you really are stronger together than you are apart. And so you really do have to be able, especially working in NASA, we're all part of a large team. And so you have to be able to work harmoniously and really understand where people are coming from to find a good compromise that everyone is happy with.
Awesome. And you know, I'm just noticing it is the top of the hour, and I know that many of you may have to depart or dismiss or go to your next class. For those of you that do have to depart, first of all, thank you for joining us today. Thank you for your input, answering your questions, asking questions. And I definitely want to say thank you to Sam Lawrence for sharing his expertise and all this wonderful new information with all of you. So again, we're at the top of the hour. We'll officially come to a close. However, Sam, are you willing to stay on another couple more minutes so we can answer a few more questions for groups that stay on the line? But again, those that have to depart, thank you so much. Be looking out for my next email on our next upcoming webinar, seeing our actual lunar samples and our lunar curation facility. We're looking at November 6th for that. I will send out an email so that you can consider joining us and you can register for that event. So stay tuned for that. And again, those still on the line, we'll see what other questions we can get answered from our expert here, Sam. So have a great day, those of you that are departing, and we'll continue on. Now, Sam, I did want to go back to this whole idea of teamwork and these skills. Would you also say that it's important to be able to listen to the differing viewpoints, to be able to not shut them out and be like, no, that's totally wrong, but to listen?
Yes.
And does that happen often in teams?
It happens all the time. Yeah, you really do have to you have to work together. So that means listening to a lot of diverse people.
And sometimes people who can convince others to join their camp and whatever it is they may be thinking about. So, and I would say studying hard, taking lots of math and science types of classes. Computer programming is another really good one. And always being open to new opportunities. That's right. There's something for you all to think about as you because we're going to need some lunar scientists.
It looks that way.
Yeah, especially if the moon is it's only 3 days away, so we got to continue exploring. All right, so let's see what groups that we might still have on the line so I can target some of their questions. So it looks like we have quite a few still here. Palm Springs, one of our groups from Florida, Palm Springs North Elementary, they're wondering any estimate of years on when you think people might live on the moon?
That's a really good question. It always seems like we always seem to be about 30 years away from that. And I think right now there's no fundamental technological challenge. We know everything we need to know. We've landed on the moon before. It's not a mystery. I think the real issue right now is who's going to get back there first. And I know that there are many nations interested in doing it. So my sense is that it'll happen eventually, and probably within the next 20 years, which is the answer that I always seem to give at these things.
So another 20 years. You're still going to be working here, right? No retirement, huh? Yeah. Let's see what we have as some additional questions. I'm searching. Actually, yeah, there was a question that came in on time. J.H. Rose School, they were wondering, and they're from Greenville, North Carolina, how long is it from morning till noon on the moon?
It's about 7 days.
About 7 days from morning to noon.
Yeah.
Well, that was not the answer I was expecting, but that's fascinating.
A lunar day is 2 weeks.
Awesome. Wow. So
2 Earth weeks.
2 Earth weeks. Excellent. So how old, this is a question from Murfreesboro Middle School, how old is the moon and how can you support that answer?
That's a really good question. So keep in mind we've only landed in 6 spots on the moon. And so we're drawing heavily from inferences that are made from what I would regard as not a lot of direct exploration. So keep that in mind. But based on what we did discover when we went there, the answer seems to be around 4.5 billion years ago. So we think that the Earth formed in the nebula, the early solar system nebula, and then at some point it got hit by a large asteroid, really big asteroid, something the size of Mars, and that broke off the chunks that eventually coagulated to form the moon, and that would have been around 4.5 billion years ago. And we think that is the case because of radiometric age dating of samples that were collected by the Apollo astronauts.
Yeah, we have, is it the Genesis sample, one of the oldest samples?
Yeah.
And that has really helped contribute to some of this understanding. So our oldest sample, I don't know if when we do our webinar of the Lunar Lab, if we'll be able to showcase that Genesis rock, but it really is a rock that has helped provide a whole lot of information. Awesome. Now, Harmony Hills, they are a group that is from San Antonio, Texas. They're wondering, and we'll see how you can answer this, is the core of the moon warmer than the outside? And can you give any...
Based on how other planets work, that's almost certainly the case, but I can't put exact numbers on it.
All right. Now, John Kerr Elementary, and you kind of mentioned some of this earlier. If there were living organisms on the moon, what could they feed on? Now, there aren't any living organisms that have been found, but if there ever were, what could they feed on?
That's a good question. So like I said, there's nothing living or alive on the moon right now. And so if you did go live there yourself, you'd have to grow your own food. And as it happens, this unit, Ares, was at the forefront of such research in the 1990s, and last time we were planning on building a lunar base. And it turns out you can actually grow crops in lunar soils. You have to add in a couple of little nutrients here and there, and you can actually use lunar soils, lunar regolith, to grow crops. And so at some point in the future, people will be growing corn and other stuff on the surface of the moon.
Awesome. Well, we look forward to seeing that.
I do too.
Let's see if, looking at some of the schools that are on the line and some of the questions that I see here. Here's an interesting question I'm not sure you can answer, but the Apollo missions were the missions where we had Apollo astronauts landing on the moon. What about Artemis? I guess Artemis is the goddess of the moon. This is what I'm learning from Edna Drinkwater School. Would they ever name any future missions, or are there even ways you can name missions like Artemis?
I'm sure many missions. I think there's been several missions, proposed missions in Artemis. The Apollo was actually not originally intended as a lunar vehicle. It was named after Apollo simply because the managers thought the image of Apollo driving his fiery chariot across the sky was a good one. And that's why they picked it. And then when John Kennedy made his epic 1961 pronouncement to send the United States to the moon, Apollo became the lunar spacecraft, but it was actually named before that.
Interesting. And I know with some of the Mars missions, they oftentimes solicit names and ask for members of the public to provide potential names. So who knows? Keep your ears and eyes open. Maybe there'll be some opportunity.
Space Shuttle was named by school children.
Oh, was it really? Yeah. And actually, so was Curiosity rover.
And Student Opportunity.
Absolutely. So keep your eyes open for those types of things. And if I hear of opportunities like that, I'll certainly let you know. Now, J.H. Rose High School, they want to know what's the daytime temperatures. And I'm going to add in the nighttime temperatures on the moon.
Slides here. Let me make sure I got this.
And that's a really good question, because I know that the temperature swings are probably going to be somewhat very variable. But we're going to try to see if we can get you some actual data on that. So stand by. And you even think about our temperature, our daytime temperatures, and I would certainly think that, let's see, J.H. Rose High School is in Greenville, North Carolina. Their daytime temperatures are going to probably start getting lower and lower and as we get into our winter here. But
so the daytime temperature winds up being around a little over 200 degrees Fahrenheit. The nighttime temperature can be as cold as, I'm sure I got this right, the coldest place on the moon is about negative 415 degrees Fahrenheit.
Negative 4.
That's the coldest place in the solar system.
Wow. In the solar system?
Yeah.
Wow. So I think 0 degrees Fahrenheit is cold. You're talking 415 degrees below 0
That's
Fahrenheit.
correct, yes.
That's a little cold.
That's great.
Great question, Jay Troes High School. Now, PAC 94 is asking, when we have a habitat on the moon, will we still only be able to live on one side since the far side never seems to see light?
Okay, so let me put a fork in this right now. There is no dark side of the moon. The far side.
Did I read that wrong?
No, you read that right.
Okay.
So the far side of the moon actually sees a lot of light. It sees the same amount of light as all the rest of the moon. We just never see it from Earth. The Dark Side of the Moon is a Pink Floyd album, but it's not actually reality. We will still be able to see. We can live anywhere we want to on the moon, and you'll be able to see the Earth from the near side, and you'll still get sunlight on the far side too.
Yeah, that near side and far side, I think oftentimes people hear of it as the dark side,
right,
even though it is only considered the far side. And just from the global views you showed from LRO, we can actually see it was quite lightish in color compared to the dark patches on the near
If we
side.
never receive sunlight, we'd never be able to take pictures of it.
Yeah, that's interesting. And what are those dark patches versus the light patches when our folks are looking up at the moon on International Observe the Moon Night?
So the dark patches are Mare basalts. They're very similar, for anyone who's ever been to or seen movies of Hawaii, they're very similar to the Hawaiian Islands. The white patches have no terrestrial equivalent. They're a mineral called feldspar, and we think they're remnants of the early lunar crust.
And, I'm going to send these folks a link to a video made from Goddard, I believe, that shows the history and evolution of the moon, kind of from the impact and then the melting and then all. It's a great video that helps to be able to.
That's a good one, yes.
To see and to gain a grasp of how the moon has evolved over time and the heavy bombardment periods and volcanism. So I'll send the link out to you teachers so you can share that. 2 more questions, Sam, and then maybe we'll let your voice have a break. So PAC 94 is wondering, if we were to put a base on the moon, what would be used as an energy source?
That's a really good question. So as I sort of alluded to previously, there are areas of the moon where the sun never stops shining, which means it's perfect for solar power. We almost certainly use solar power at the beginning. And then in the future, you might see other technologies like nuclear power.
And nuclear power, it doesn't matter what your temperatures are, you're going to get a lot of power and energy.
That's right.
And they use nuclear power sources for the MSL rover on Mars.
That's right, yeah.
Yeah, so interesting. Last question from Murfreesboro Middle School. It's the last one I see here. I don't know if you can answer it, but what is the largest meteor that we potentially know about that has hit the moon?
That's a very, very good question. It's in fact a critical question if you're designing a lunar habitat because you want to be able to protect the astronauts from any hazard they may see. So our mission has been taking before and after pictures all over the moon looking for changes. So we've seen landslides, but we've also seen new impact craters. And so one of our major discoveries has been that we've had some recent impacts since we've been at the moon over the past 8 years. The biggest crater we've seen has been about 70 meters in diameter.
Wow, 70 meters in diameter. So if the crater is 70 meters in diameter, what's the approximate size of what struck that?
About 10.
About 10. Interesting. So, and that's the power of the resolution of these cameras on the LRO, is that you can do these before and after and see these impact craters, these recent impact craters.
To do the before and after, you have to be in orbit for a long time. So we've been very fortunate that we've had the opportunity and the money to stay in orbit for over almost a decade now. So if it wasn't for that long time in orbit where we can actually take multiple pictures of the same spot, we wouldn't be able to collect that data.
Awesome. And the health of LRO, since it's been there since 2009, the health is still good?
Still good. We have fuel for another 11 years.
Wow. Well, let's hope that LRO can continue giving us these spectacular imagery and that perhaps sometime in the next decade we can bring Sam back and have him show some of the new stunning imagery that continues to come in from the
My
spectacular
fondest
mission.
hope is that LRO is still in orbit when the next Americans step onto the surface of the moon.
Well, that sounds like an awesome thing to think
Yes,
about.
it is.
Yeah. Well, with that, it is 15 minutes past the hour. We are so thrilled for those of you that were able to continue to stay on the line with us. I hope we answered the majority, if not all, of your questions. If there's something you have that is a burning question that your student has, you can feel free to email me and I'll see if I can get you an answer. But with that, we're going to bring today's session to a close. But before we do, don't forget, October 28th, this Saturday, International Observe the Moon Night. If you do nothing else, look up at the moon, think about what you have learned about the moon today. Know that our moon is only 3 days away and that exploration will continue. And remember that a lot of what you've learned perhaps came from our guest speaker today, Dr. Sam Lawrence. So Sam, thank you so much for sharing your expertise, your passion, your knowledge. And for those of you out there, thank you for joining us today. And with that, any closing remarks before we bring it to a close?
No, it's time to get back.
Sounds good. Time to get back. So thanks, everyone, for joining us. Danny, you can give me back host privileges, and I'll take it from here. And we hope to connect with you again in early November, so stay tuned for that. Thanks, everyone.